Hello everybody. Today we are going to write a program in which we would have an array in which there are certain elements A, B, C, D, E, F, G, H, I. What we are going to do is we are going to insert a new element in the existing array and push the rest of the elements down. So we have to insert an element at the nth position in the array. This is what we are going to do. Now, to implement this program, I have started implementing this program in which I created a headers.h header file in which I have declared these two headers. Then I have created a declarations.h another header file in which I have declared the getArray function and a macro that will help us take the size of the array at runtime. Then in the main function, we have started implementing the main function. Both the header files which I showed you just now have been included, and I declared a pointer which is going to be the pointer to array. So I enter the size of the array, you get the size of the array in n, then you call the getArray function and supply the size as argument, and you are in getArray function. The getArray function starts with the size of the array here. We declare a new local pointer and allocate space for the size of the array as is given here, and the memory will be allocated for the array. Now the general check, if not ptr, then you will report error using p error. The p error is required for reporting errors because p error will use the file descriptor number 2 to report the errors, though it is redirected down up to your file descriptor number 1 for default output only. But we have to adopt this practice right from the beginning, that the errors should be reported through the file standard error stream that is connected through the file descriptor number 2. So you report the error and exit your program. That's it. Otherwise the memory is allocated. Now if the memory is allocated for the array, then you fill it with the values. Give a prompt for the user. Enter array elements. You'll have to use the for loop for this. So use scanf and put the values in here. %d, and you get all the values in the array. The array is pointed to by ptr plus index I, which will keep on incrementing and go till size. And now your array is filled with values. Then you return the pointer pointing to the array. I have explained to you that it's a local pointer. It will get destroyed when the function will get over. But before it gets destroyed, it must return the address it contains. Can somebody tell me what is the data type of ptr?
Int.
No. Who was that?
Integer pointer.
Integer pointer. So therefore you update the prototype. Program evolves. Declaration evolves. The return type is integer pointer. Okay. Now your function is complete and it returns the starting address of the array that you just created and filled with values. So that is captured in ARR, another pointer. The address that is returned from the getArray function, which is the starting address of the array, is now returned. Address is returned and captured in ARR, which is a local pointer inside the main function. Now, just a recap. The pointers are declared local. So therefore, the pointers would go inside the stack segment. Whereas the dynamically allocated memory, which is allocated using malloc, is allocated from heap in the data segment. So therefore, memory will be allocated in the data segment. And memory in the data segment is not destroyed automatically. Therefore, when the function is over, the pointer is destroyed, but the memory is not destroyed because it is in the data segment, isn't it? So in our case also, the same thing happened. The memory that was pointed to by this ptr after malloc is in the data segment, and the pointer is in the stack segment. The memory in the data segment, I'll come to that. The memory in the data segment is not destroyed automatically, though when the function will be over in the line number 21, return ptr. After that, the pointer is destroyed, but the memory pointed to by this pointer is not destroyed because it was in the data segment. Now, very famous interview question. Why the memory allocated for a local variable gets destroyed, but the memory allocated for dynamically allocated using malloc is not destroyed? The answer is straight, because the dynamically allocated memory gets allocated and is listed in the data segment, and the memory in the data segment cannot be freed automatically. The scope is not limited to the function, therefore it is not destroyed automatically. It continues to exist unless it is exclusively freed or the program is over. Okay, so the pointer is destroyed, but the memory is not. So therefore the address of the memory in the data segment is returned back and is captured in another pointer in the main function, again in the stack segment, but the memory is in the data segment. Now we have to insert. So let the user ask. Okay, now we call the insert element function because we have to insert the element at the nth position. Look at this, isn't it? So insert function, int insert function. Now you're going to insert some element into an array. So you return the array. You give the array as an argument. Int star goes as an argument. This is the array into which you will insert some value. Okay, which value will you insert? Well, you will insert this value, int. You may not be able to realize what is a prototype. Maybe you are declaring here, you're not able to think, oh my god, what will be the prototype, what will be the arguments, what will be the return type. Sometimes you're not able to figure out. Don't bother. If you're not able to figure out what will be the prototype, you just take a default return value integer and you leave the argument list empty and go ahead with this design. So we have a insert function with the, I don't know what arguments, but you make a call to the function and let's go ahead here. So this is the getArray function. Let's have another function now. Here we are in insert function. Return type is default is integer. Name of the function is going to be insert. I don't know what are the arguments. You'll leave it for later and delete the other stuff. Now let's start insert function. Very first thing you need is this value which has to be inserted, isn't it? Now the question is, do you have this value? Have you taken this value?
So we have the base pointer. We can increment it accordingly and shift the rest of the element downwards.
So right now the question is, do you have the element to insert?
No.
You don't have that. We need this j
No,
that
sir.
you're going to insert. So you have two choices. Are you going to take this value as obviously you have to take this value as input. So what is your thinking? Do you want to take this value as input in the main function, or do you want to take this value as input in the insert function? Where would you like to take this value to insert? Your choice, tell me.
I think main is okay.
Okay, you want to take it in main? We'll do it in main. So enter the element to insert in the array. Okay, and scanf. Percentage C. Here is the element. Say E is the element. Okay, declare E as an integer. Now this E is the element that you want to insert. Come back to this. Do you have E here in the insert function? Do you have it here? Yes, no?
No.
No.
We don't.
Where is
No,
it?
sir.
It was in the main function. E was in the main function as suggested by Dinesh. So how would you bring this E from main function to this function?
We have to insert the pointer address of E in the insert.
Pass as an argument, sir.
Yes,
So pass
yes,
as
you will
argument.
pass as an argument. Wonderful.
Yeah, pass
So
as
E
an-
will be passed as an argument. Dinesh, you are able to think, but try to keep things simple. So you will pass E as an argument. What is the data type of E?
E is
Integer. So therefore,
Integer.
tell in the prototype declaration that you will pass integer as an argument. Oh, sudden realization. So therefore, there was no need. You wouldn't have had a wildest idea in the beginning that the insert function will take this element E, which is of type integer, as an argument. You couldn't think it then, and that means you were thinking the right thing at the wrong time. So leave it for now. A sudden realization we had now. Okay. Then after that,
Good evening, sir.
good evening. So let's go to the insert function. You realize that you have an integer e as an argument, which is the element that you want to insert. Fine, let's start. So e has to be inserted at position. What is the position? Where do you want to insert? The size of the array is n. Say n is, suppose n is 10. So you will insert at location 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Where would you like to insert? Which location would you like to insert your e?
I think ask the user.
Ask the user. Very good. So where would you like to ask the user? In the main function or in the insert function?
Main function.
Main function. Fine. So another prompt. Enter the location to insert the element. Location. Suppose the location is going to be stored in a variable called L. So you take the input in L. Fine, you have the location now. So let's go to the insert function and start inserting in L. Do you have this insert function? Inside the insert function, are you able to use L?
No, sir.
No.
No. What would you do then?
Take it as an argument.
Again, take it as an argument. Wonderful. So L will also go as an argument. Here it is. Realization. Oh, we have to pass another integer. Go to the declaration and set it that you have another integer being passed as an argument to the insert function. Then int loc location. Isn't it? Let's start now. We have the ingredients, the input that our insert function needed. Now we will go to the location position. So suppose this is the array, location is loc here. Now this is loc, and e is the element. Suppose j was your element, isn't it? J. I want to insert j here, but if you insert j at this position, then your f will get overwritten. So what you have to do is you have to bring everything down. Tell me, you will bring everything down, this first, this, then this, then this, then this, or the reverse order? First this down, then this down, then this down, then this down. You will go top up or bottom up? Top down or bottom up?
Top down, sir.
If you go top down, then you shift F down, F comes over G, and G is overwritten and lost forever. So top down would not work. If you go bottom up, you shift I down, okay, now you have I here and I here, you have two I's. Then you bring H down, H overwrites I, fine, but you have an actual copy of I here, so I is maintained. So you should go bottom up to shift everything down. Are you able to understand?
No, sir.
Yes, sir.
Yes, sir.
Dinesh?
No, sir. No, sir.
What I'm saying
I'm
is,
just thinking that.
see what happens, you think but I'm speaking about, okay? When I am speaking something, you have a good mind, but at the moment when I am explaining you X, you are thinking Y. So what is happening is, you are thinking and my speaking and you're listening, three things are not going in sync, okay? So what you should do is, you should first of all explain it to yourself, that the things that you're going to do with me are very simple, okay? And these are not complex, these are very simple things. The only thing that you are doing this is because you are doing it for the first time in your life. Otherwise the things are simple. Okay, now think only what we are discussing. Now see what happens. Suppose you shift F down, so F will be shifted down and F will come here. When the F comes here, you have F here shifted down. Did you notice that the G is overwritten and lost forever? So that's why you should not start shifting from top. Other option, start shifting from downwards. You shift I down first, okay? Then you shift H down. H comes here, overwrites I, but it's fine because I has already been shifted down. So that's what I was trying to say, that when you have to shift downwards, start from down. When you shift upwards, start from up. Okay. So this is what we need to do. Yes, tell me.
So my question is that we have allocated this much of array index, like let's say last one is the index number 10 and next is I. Once they shift it down, I is the bottom one. So that
uh,
means, so what is the index of for that one? So because that is not in our in the range of the array which we have initially
so what you're trying to
declared.
say is the array needs to be expanded.
Right, right.
Exactly. What you're thinking is true. Very true. We will learn now how to expand the array. So what is the original size of array in our program? We had taken n. See this? We had taken n as the original size of the array. Did you remember this? Then we passed this n to the getArray function, and the getArray function took n as an argument into size, and the getArray function allocated that much memory. You saw that, isn't it? So n is the size of the element, the size of the array. Okay. Now when you called this function insert, you should pass the size of the array also. You have to pass the size of the array n also, because n is known only inside the main function. N is not known inside the insert function. So you have to pass n as an argument. So you have another integer coming as an argument. Are you following this, everybody? Please respond to me in the chat, yes, no, or question mark if you have any question.
So this thing is clear, but the index मेरा वो दिमाग आ रहा है कि if you shifted I is the bottom one, then I के लिए तो मेरे लिए
Dinesh, I am repeating my advice for you. It is very good that you are able to think slightly ahead, but you will benefit greatly as you asked me question already once, and I told you that I will tell you that how to expand the array. Now you must bring three things in sync. Me speaking, your listening, and your thinking should be in sync. Then you'll be able to learn much better. Okay, now we have passed the size of array also as argument to insert function, and we go to insert function. Okay, see how we are evolving it. Int n. Suddenly you realize that what all things are needed in this function. Now let's start. So you straight away go to the location. See, understand this. This is the LOC, location. From location till the end of the array, everything has to be shifted down. But before shifting, you have to expand the array, isn't it? Let us first expand the array. The array will be expanded using realloc. Malloc is used to allocate memory, which we have already done here in getArray. Realloc is used to resize the allocated memory if allocated. Now the pointer that is pointing to this memory that has to be allocated, the pointer that is pointing to this array has to be used to allocate, to understand which memory has to be expanded. So what is the name of the pointer that points to the array that needs to be expanded? Can you tell me what is the name of the pointer that is pointing to the memory array that needs to be expanded? What is the name of that pointer?
PTR.
PTR. PTR we had declared in getArray local variable, and the PTR has already been destroyed, but because when the function was over, the local pointer was destroyed. So PTR is not the solution, not the answer.
n size of n.
N is the size of array. The starting address of the array is stored in a pointer. So we have to mention the pointer here. Realloc takes arguments. This arguments, watch this. The realloc system call works like this. Realloc. It takes pointer to memory. Please switch off your microphone. Mute your microphone, whoever is switched it on. Microphone should be on when you ask question, then again switch it off. And this is new size. which will return after resizing pointer to memory. This is how reloc will work. Okay. Now my question is pointer to memory. What is this pointer to memory that whose size has to be changed? Means we have allocated memory. Where have we stored the starting address of the allocated memory? Pradeep made an attempt to explain us that the memory, when it was allocated, the starting address of the memory was stored in PTR. That was correct, but that was correct until the end of the getArray function. Then the getArray function was over and the PTR was destroyed. But before destroying, the starting address of the allocated memory was returned and was stored in ARR. So ARR is the pointer that contains the starting address of the memory whose size needs to be expanded. Okay, so shall we use ARR here?
Array pointer.
ARR? Can we use it here? Yes, no?
Yes, sir.
So we don't have the variable, I guess.
We can't use it. Pradeep, we can't use it. Because ARR was declared local inside the main. So ARR could be used only inside main function. ARR could not be used in the other function, the scope rule. So what would you do in this scenario? You need the address of the pointer pointing to the memory. You need that pointer inside your insert function. What would you do?
Take it as an argument, sir.
You have to pass it as an argument. So ARR will also go as an argument. Here it is. Suddenly you realize, oh, ARR will go as an argument. What is the data type of ARR?
Pointer int.
Integer pointer. So you have to mention, update your declaration. Integer pointer will also go as an argument. Suddenly you realized it. This is why software is called software development, not writing. Because there is a realization in every step. Int star PTR is now pointed to your array. You can give it any name. So you have a PTR is a pointer whose size has to be relogged, changed. What is going to be the new size? Well, the new size is going to be n plus 1 elements. Array expanded. And the starting address of the allocated memory will be stored back in PTR same pointer. You must check for errors if any. P error from malloc, reloc will be printed. Exit. Failure will be printed. Very nice. So the size has been expanded. Now the size has been expanded. Now we can do our stuff. What is our stuff? Our stuff is to shift all the elements from I to F downwards. I to F, remember. So we'll run a for loop which will go from I to F. We'll run a for loop. You need a loop variable here. Int I. Int I. So I will go to n minus 1 to until unless I is greater than LOC, greater than or equal to LOC. I minus, it will come down, shift the 8th element, then the 7th element, then the 6th element, like this. Isn't it? You will move the ith element down. You will move it like this. The value stored in array plus ith location will be moved to value stored in array plus I plus 1th location. That's how you'll move the array down, and then your LOC value will have shifted down. Everything shifted down. Now you can store the element at the LOC location. PTR plus LOC location will have the element that you want stored in the LOC, because everything else has been shifted down and LOC is made replicated, and there our element is inserted down. Okay, so there is no need to return anything because the original address of the array is already there with your main function. We just have to do is display. We need a display function. We need a display function. We have to display the array. The display function will display here also. Display the original array, and then after insert, display the array with inserted element. Let's write the display function now. Display function. The display function is here in the display.c file. So to display we need a for loop which will go from the beginning of the array to the end of the array. The for loop. 0 to I less than what? You have to display array till
So length of the array.
till the length of the array. What happened to the rest of the people? Length of the array. What is the length of the array? What should I write here?
So n in the previous function, when
N in the previous function, because the n was declared in the previous function as a local variable n, therefore n could be used only inside the main function and nowhere outside main function, but I have to use in the display function. What would you do?
pass it as an argument.
Pass it as an argument. Awesome. So we need to pass n as an argument. Here it is in both the display functions. N is an integer, so come to the prototype and say that you are going to pass an integer as an argument. This is how you do program development. So you capture n here, int, and say this is the size of the array. Okay, very good. Now it will go I less than size I plus plus. You have to display the array, printf. You have to display the location index and then the value. This is the location, and then this is the value. Location you will display with the width of 2, and the value also you will display with the width of say 3. Okay. Now the location is I, which is going to 0, 1, 2, 3, 4, 5, 6 up till n, and the value will be value stored in array plus index. What is the array name? What is the name of the pointer that is pointed to the beginning of the array using which you will do the display? What is the name of that pointer? Come on, somebody. Megha, Dinesh, Pradeep,
So PTR,
Abhishek.
ARR, I guess.
ARR, I guess. What is ARR and where is it declared?
So in me,
It was declared in main, isn't it? Because it was declared in main, and it was declared in main as a local variable. It could never be used outside of main, but you want to use it in display function. What would you do? Pass as an
It's an
argument.
argument.
That means ARR will also go as an argument. Realization, ARR. That's it. So what is the data type of ARR?
int pointer.
Integer pointer. So you have to pass an integer pointer also as an argument. 2 arguments. Okay, fine. There we are back in display. So it will capture the int star ptr. Okay, and then ptr will contain the starting address of the array plus index I, and your whole array will be printed. Now we have called this function twice. Once here we have n elements, so you display n elements in the display, but here you have n plus 1 elements, isn't it? So you'll pass n plus 1 as argument. Understand? Let's save all the files and save and the save and save and save all the files, and then compile only, don't link all the C files, and when you do so you get so many errors. So errors is an opportunity to learn. Let's have a look at the errors. Here we compiled it. The first error is in getArray.c function. Line number 9 says n undeclared. So getArray.c. Here we are in getArray.c. Line number 9. We have used n is undeclared because n is not known here. The n which passes the argument and captured in the formal argument called size. So this will become, instead of n, we should use here size. Okay. Any other bug? Another error was here, declarations.h. Line number 1, hash define size n. This n is not known. In definition of macro size, what is the problem with this n?
So while using the size n function like macros, I think we've forget to pass the n.
When you used it, size n, we have to pass n as an argument, size as an argument. There is the size that is going as an argument. Okay, we should use this method only when we are declaring array statically. So we are not declaring array statically, so we don't need to have this macro as arguments. So we can straight away give it 10 right here and go ahead with this. So we will use macro without argument. We'll straight away use size here. Which is 10. Enter array elements. So in that case, getArray need not pass any size. So when you call the getArray function, you need not pass size because size we have fixed now. It is not n, it is size is size, size it is size. So program further modification. So this is how it goes on. Enter the size of array, no need. You come here, you pass only array. getArray. So do you need to pass the array? Because array is not yet ready. In this array you don't have any address right now. So you should not pass array and the size as the argument. getArray will not take any arguments. No arguments for getArray. And then it will create the array and give the return back array here. When you're displaying, you will pass not the size, but you will pass array as argument, and you pass size also because the display needs to know how many elements to display. And next time when you use display, you use it size plus 1. Enter the elements to insert the array. Okay, fine. Scanf. Here again, n size of the array need not pass in the insert function. In the insert function, you will not have size of the array. Here it is. So you no need to use size. Are we using n somewhere? Here it will be size plus 1. And then n, are we using n anywhere else? No. In the display function, are we using n size? In the display, if we are passing size, yes, display size has to be passed because the sizes will be varying. So let's save all the program. So again, insert the second int, which is the size of the element is not being passed. Rest is same. Save. Save all the files. Save all the files. Make compile again. All the files compiled, and we have some bugs. It says getArray.c I undeclared. Now we have insert n undeclared, line number 15. We don't need n. This is size. Done. Program is compiled. Now link all the object files. Give the new name to the linked files, say demo, and you link all the object files. All the object files linked, and the demo is created. Run demo. There it is. Display begin. We are going to display enter array elements. It doesn't take anything. Where is the scanf gone? Get array function. We get into get array begin. Then we say get array enter array elements. It did not wait for us on the scanf. Let's have a look at this. What is the problem? Control C, terminate it. Get array function. Go into the get array function. It says get array begin, enter array elements, but it did not stop here for us. I goes from 0 to I less than size I plus plus. It should have waited for us here on the scanf.
Sir, can we use line number 19 as star ptr plus I?
The scanf always take address of variable, and ptr plus I gives you the address. If you use star, then you will be dereferencing it and you will be going to the value.
Sir, can you please open the function getter where we have defined?
Size is not going to go as an argument because the size is not supplied as an argument to get array function. The get array function does not take any argument. There is nothing called size. It doesn't take any argument. So therefore in this for loop the size is not going to be used. We have to have use as I z e size. Now it will work. Let's try once again. Compile all the files. Now link all the files. Now execute. Enter array elements. Now it stops there. Okay. So let's enter array elements. There it is. Enter the element to insert in the array. The element that I want to insert is suppose 64. I want to insert 64. Enter the location to insert the element. Well, I want to insert at location 4. Well, look at the location 4. I have 64. And the array is expanded. Earlier array was 0 to 9 elements. And now you have elements 0 to 10 elements. And at the 64th location between 88 and 99, I am able to insert my new value. This is your set of programs, set of files constituting this program. Okay. So my advice to all of you is to go back to the array's single 1D array assignment, and there are 19 programs in this. All of you have done this already, or you may have done already, I don't know, you may have done half or whatever you have done, but I want you to redo this. This time you'll use not arrays, ordinary arrays. This time you'll use pointer to arrays, and you'll use functions. All the functions you'll keep in separate files and compile them separately, then link it together. I want you to redo this assignment. By the time you finish only these 19 programs, you will make your life for next 60 years easy with respect to pointer to arrays and the functions and separate files compilation, everything easy. I will continue my discussion on this arrays and function pointers and array pointer to arrays and functions, and modular approach to programming where every function goes in a separate file. I will continue my discussion on this particular programming style throughout the next week also, and I will not move ahead in my C programming training for you until unless I am satisfied in my heart that you have learned and adopted these programming style. So don't worry that whether you will be able to learn or not. Trust me, I will stand by you until unless you are able to do this, until unless you are comfortable with the pointer to arrays and with the modular approach in programming where every function goes in separate files. Always emphasize on algorithmic approach, and then to convert those algorithms into programs. The day you'll have this ability to convert the concept into algorithm and algorithm into programs, that day you will be a C programmer. Okay, you don't need practice, you need right approach to be good in C programming. Okay, so I would really request all of you to go through this assignment, and by the time you finish this assignment, you will find yourself a much better C programmer. Okay, and if you're not able to understand or not getting concept to implement certain things, have a discussion with each other or ping me on my WhatsApp. I will associate a technical assistance, somebody who will give you constant technical assistance until unless this assignment is complete. That person will not give you solutions, will just discuss concepts with you. Solutions you have to evolve yourself. Another thing you noticed here, how the prototypes were designed. Never trouble your mind by trying to design the prototype right in the beginning. It will be through the process of program development that you will keep on getting ideas and the variables and the arguments, and the declaration of the functions will be evolving, and sometime by the time you finish the function you will have a proper declaration, isn't it? You notice how many changes I had to do. I knew this program right from the beginning till the end what has to be done, but I evolved and did mistakes and then corrected and things, all things will happen with you also. Okay, so chalo, that's all I got for you today. And tech maker and hacker, very nice inputs you have given. Rest of the people try to be more prompt and involved in the discussion. So I wish you all good luck for your assignments, and any queries you have to put in the discussion forum where we'll be able to discuss. Right, chalo, bye bye, see you tomorrow.
Bye, sir.
Thank you.
Good evening, sir.
Okay,
Bye, sir.
Bye, sir.
Bye bye.